Hello, I am A.T. Talware, working as Assistant Professor in Mechanical Engineering Department of Sanjivani College of Engineering, Kopargaon. This is my third lecture on Unit number 6, B part, Economics of Power Generation. The title of this lecture is Depreciation and Methods of Determining Depreciation. In this lecture, I am going to cover what is the depreciation and its explanation, what are the different methods to calculate depreciation. There are three methods. First one is a straight line method, second diminishing value method, and third sinking fund method, and at last we'll solve some numerical to determine depreciation charges. So we'll see what is the depreciation. This term, some of you might be thinking that it's a new term, but unknowingly we are using this depreciation in day-to-day life. For example, suppose if we purchase the motorcycle today or at the cost of rupees 80,000, and if you want to sell this after 15 years, that is useful life, if you want to sell it, will you get the 80,000? No, obviously no, because the motorcycle deteriorates with respect to time because of wear and tear. So we won't get rupees 80,000 after 15 years. So we'll get, let us say, 5,000. So in 15 years, so the value of the motorcycle has been reduced from 80,000 to 5,000. This is what we call the depreciation. Okay, let us will see the actual definition of the depreciation. The decrease in the value of the power plant, equipment and building due to constant use is known as depreciation. So this depreciation term is concerned used for power plant. So that's why the uh, in the definition the plant equipment and building is used. So why there is the need to determine the depreciation charges? Why it is so important? Due to depreciation, as I told in the last example, that is example of motorcycle, the value of the motorcycle decreases with respect to time. In the similar way, the value of the power plant also decreases, and at the end of its useful life, let us say 30 years, 40 years, we have to replace the old existing power plant with the new power plant. So we have to collect some amount every year, and this amount so collected at the end of useful life of the power plant, we can use this amount to construct the new power plant. That is the concept of depreciation charges. Therefore, a suitable amount must be set aside every year so that by the time the plant retires, the collected amount by way of depreciation equals the cost of replacement. It becomes obvious that while determining the cost of production, annual depreciation charges must be included. What is annual depreciation? Annual term refers to the per year. From the time the power station is installed, its equipment steadily deteriorates due to wear and tear, so that there is a gradual reduction in the value of the plant. This reduction in the value of the plant every year is known as annual depreciation. Let us will move to the next part, that is what are the different depreciation methods. There are three depreciation methods to calculate the depreciation charges. The first one is the straight line method, second one is the diminishing value method, and third and last method is sinking fund method. Let us will learn one by one. First, straight line method. This is the simplest method. We can understand this with the help of this diagram. In this diagram, P is considered as initial cost of the equipment, that is considered on the y-axis, and N is the useful life of the equipment in years, so that is considered on the x-axis, and S is the scrap or salvage value after the useful life of the plant. I will get back to the same example of the motorcycle, that if you sell that motorcycle after 15 years you will get 5,000, so that 5,000 is nothing but the salvage value or the scrap value. So here we have considered S is the scrap value. So initial value of the equipment is P rupees and salvage value or scrap value is the S. Next, the annual depreciation charge means per year how much is the depreciation. How much is the total depreciation? How to calculate? Total depreciation is mentioned here on the y-axis, that is P minus S. In how many years? In n years. So per year will be P minus S total depreciation in n years. So for 1 year we can divide by n. So this is the formula for calculation of the depreciation charges by straight line method. Let us consider one example to understand this. Initial cost of the equipment is 1 lakh rupees. The scrap value, that is after useful life of 20 years, is 10,000. Annual depreciation charges is equal to total depreciation is 1 lakh minus 10,000 divided by 20. What does it mean? It means that the value of the equipment is reduced from 1 lakh to 10,000 in 20 years. So for 1 year how much? So for 20 years the value is total depreciation is of 90,000. So 90,000 divided by 20. 90,000 is the total depreciation in 20 years. So for 1 year it will be 4,500. One more example we'll see. This is a transformer costing 90,000, has a useful life of 20 years. Determine the annual depreciation charge using straight line method. Assume the salvage value of the equipment to be 10,000. Okay. So what are the given terms? Initial cost of the transformer is 90,000. Useful life is 20 years. Salvage value 10,000. Using straight line method, annual depreciation charges. So P minus S upon N means that is equal to 4,000 rupees. Means 4,000 rupees we have to keep aside per year, so that for 20 years we can accumulate 20 into 4,000. How much? It will be 80,000. And the salvage value scrap value is 10,000. So that at the end of 20 years we can accumulate 90,000, so that we can replace the existing transformer with a new transformer. Okay. That is the concept of depreciation charges. Let us will move to the second method, that is a diminishing value method. Diminishing, what is the literally meaning of diminishing? Diminishing means decreasing, means the value will be decreases. Okay, so in this method depreciation charge is made every year at a fixed rate on the diminished value of the equipment. In other words, depreciation charge is first applied to initial cost of the equipment and then to its diminished value. So this as an example, so this method can be well understood by considering one simple example. Through example, we can understand this. Let us say the initial cost of the equipment is 10,000 and its scrap value is 0 rupees. Means we won't get any amount after selling it after its useful life. So how much will be the if the annual rate of depreciation is 10%, means per year 10% value will be 10% of initial value will be decrease in value. Then depreciation charge for the first year will be 10% of 10,000 is 1,000. Means for the first year the value of the equipment will be decreases by 1,000. Means the value of the equipment is diminished by 1,000 and becomes 9,000. Means 10,000 minus 1,000 is 9,000. For the second year, the depreciation charge will be made on the diminished value, means decreased value. What was the initial cost of the equipment? That was 10,000. At the end of first year, its value will be decreases to 9,000. And at the end of second year, for the second year depreciation charges is 10% of 9,000 is 900. Now the value of the equipment now becomes 9,000 minus decrease the value decrease in value is by of 900. So the value of the equipment at the end of second year will becomes rupees 8,100. In the similar way we can find out the for the third year the depreciation charge will be 10% of the present value of the equipment, that is 8,100, that is rupees 810, and so on. Let P is the initial capital cost of the equipment, that is initial cost, N is the useful life of the equipment in years, and S is the scrap value of the after useful life. Suppose the annual unit depreciation is X. It is desired to find the value of X in terms of P, N and S. So let us will derive the expression for X. X is nothing but the annual unit depreciation. X is nothing but annual unit depreciation. So expression of this will calculate. So how will understand again that by considering this, that is we'll derive this expression value of the equipment after 1 year. So what was the initial value of that equipment, that is P rupees, and its value will be decreases, that is unit annual depreciation is X. So P into X, so this means is the decrease in value. So how much is the value of the equipment after 1 year? P minus PX. Next, value of the equipment after 2 years, that is diminished value minus annual depreciation. The initial value of the equipment was P rupees, its diminished value will be P minus PX, and annual depreciation will be X times the present value, that is P minus PX. So if we solve this, we'll get this in terms of, that is P in bracket 1 minus X raised to 2. It means that for value of the equipment after 2 years will be equal to P in bracket 1 minus X square. Now therefore the value of equipment after n years we can calculate, that is p in bracket 1 minus x raised to n. So for 2 years we have considered here power of 1 minus x is 2. For n years similarly we can take the power of 1 minus x as raised to n. If annual depreciation is 10%, then we can say that annual unit depreciation is 0.1. So this is important for calculation of the depreciation charges. So we have to convert this 10% annual depreciation in terms of annual unit depreciation by dividing 100. But the value of the equipment after n years, as I told you that after n useful life, whatever the value of the equipment is, that is called as a scrap value, and that is equal to the scrap value S. Therefore, the S is equal to P in bracket 1 minus x raised to n. So from the previous slide that P in bracket 1 minus x raised to n is considered. So by solving this, we will get the expression of x is equal to 1 minus s divided by p raised to 1 by n. From this above expression, the annual depreciation can easily be found. Thus, depreciation to be made for the first year is given by x into p, that is x is replaced by this above term. So this is the final expression for the depreciation for the first year. Similarly, annual depreciation charge for the subsequent years can be calculated, and the nature of graph between P, that is initial cost of the equipment, versus the useful life will for the diminishing value method will looks like this. Now we will go to the third method, that is the sinking fund method. So in this method, so what is the main features of this method is that whatever the amount we are taking aside, so that amount will invest in the bank, and will earn the interest on that invested amount. So that amount will be considered in the sinking fund method, which was not considered in the first two methods. And the constant depreciation charge is such that the total of annual installments plus the interest accumulation equals to the cost of replacement of equipment after its useful life. So this method can be understood by again consider all the terms as usual. P is the initial value of the equipment, N is the useful life of the equipment in years, S is the scrap value after useful life, R annual rate of interest expressed as decimal. Cost of replacement will become P minus S. Let us suppose that an amount of Q is set aside as depreciation charge every year and interest compounded on it, so that an amount P minus S is available after n years. An amount Q at annual interest rate R will become Q in bracket 1 plus R raised to n at the end of n years. So this is the simple formula which we have used in the high school days, that is compound interest. How much amount will we will get at the end of n years if we invest q rupees per annum. Let us will understand this how this expression has been derived. So for that, so let us consider the this diagram, that is q rupees. Here q rupees has been invested, and at the end of first year the amount will becomes q plus rq. Okay, so Q plus RQ. So now how the interest on the Q is this R into Q, that is considered here, and again we'll invest this amount Q plus RQ in the bank, and we'll earn the interest on that at the rate of RQ plus RQ. So at the end of second year, so we'll get the amount equal to Q in bracket 1 plus R square. So at the end of first year, amount is Q plus RQ. So in this diagram, the RQ in the at the top left, that represents the interest on the top side, and at the bottom side this will be the total amount collected. So at the end of first year, amount Q becomes Q plus RQ. At the end of second year, amount is equal to this uh, Q plus RQ, that is a principal amount, plus interest on that, that is R into Q plus RQ. So subsequently we'll get this expression. Similarly, at the end of n years, the amount will becomes Q in bracket 1 plus R s to n. So in order to understand this sinking fund method, let us again will uh, consider the same diagram. Here Q rupees have been invested, kept aside per year, and that will be deposited in the bank. So when we deposited the Q rupees at the end of first year, so how much interest we can earn, for how long this Q rupees will be invested? So for first year means 0 to 1 year, there is no interest, we cannot earn the interest, but for rest of the year means n minus 1 year we can earn the interest on it. So at the end of n years, the amount will becomes Q in bracket 1 plus R raised to n minus 1, because for the first year we won't get the interest on it. Similarly, at the end of second year, the same amount Q will be deposited in the bank, and how much will be the interest will be earned. So this is the amount which will becomes at the end of n years. Similarly, this amount will becomes amount when we deposited Q amount at the end of n minus 1 year. So, so this is the total amount which will be collected at the end of n years. So again the same is explained here. Amount Q deposited at the end of first year becomes this Q in bracket 1 plus R raised to n minus 1. Amount Q deposited at the end of second year becomes this Q in bracket 1 plus R raised to n minus 2. Similarly, and so on, the total fund after n years. So how much is the total fund will be accumulated? That is addition of all this is nothing but the total fund accumulated. So we'll go on adding the fund collected. So Q is the common. We can find out the total fund after n years, same as I have carried out on the present slide from the previous slide. Now this is the geometric progressive series, and its sum is given by total fund is equal to Q in bracket 1 plus R raised to n minus 1 upon R. So this total fund or amount must be equal to the cost of replacement of equipment, because after all we are accumulating this or collecting this amount so that we can replace the existing equipment with a new equipment. So how much fund is required? The fund equal to the P minus S. So this much amount of fund is required. So this is equated with P minus S is equal to this. By solving this, we will get the expression for the Q, the as this. The value Q gives the uniform annual depreciation charge. The parenthetical term, this is parenthetical square term, a square bracket term, that is parenthetical term in equation 1 is frequently referred to as sinking fund factor. So sometimes we need to calculate the sinking fund factor. So that will be calculated by using this parenthetical term, that is r upon 1 plus r raised to n minus 1. Though this method does not find very frequent application in practical depreciation accounting, but it is the fundamental method in making economy steady. So this is all about the theory part of the depreciation and the depreciation methods and their derivations. Now we'll consider some numerical to apply this theory to solve the numericals. Let us consider a numerical. A distribution transformer cost rupees 2 lakh and has a useful life of 20 years. If the salvage value is rupees 10,000 and rate of annual compound interest is 8%, calculate the amount to be saved annually for replacement of the transformer after the end of 20 years by sinking fund method. So the method by which the depreciation is to be found out is clearly mentioned in the problem statement. So we have to use the sinking fund method. So what are the given terms? So initial cost of the transformer is P equal to 2 lakh rupees. Next, salvage value of the transformer, that is 10,000 rupees. Useful life of the transformer is 20 years. Annual rate, interest rate R is equal to 8%, that we have to divide by 100 and will becomes R is the unit annual depreciation rate, that is 0.08. And annual payment for sinking fund means per annum how much amount we have to keep aside, so that at the end of 20 years we can collect the amount equal to 2 lakh rupees, so that we can replace the existing transformer. So we can use the formula Q is equal to P minus S in bracket square bracket R upon 1 plus R raised to n minus 1. Here P is the P, S, R and N are the terms as I explained in the previous slides. Now keep all these values, so we'll get rupees 4,153 rupees per annum. So this much is the amount we have to keep aside per year, so that we can accumulate rupees 2 lakh at the end of the 20 years. Okay, by including by collecting the 10,000 is the scrap value of the transformer. Okay, thank you.